Okay, class, hope your week's been going well. Hey, here's the answers to the review questions. And class, please remember, if you're not able to do the review questions, you're not going to be able to perform well on the quiz nor on the test. What should you do? So there's a couple things you can do. Number one, watch my quick review videos. Watch the quick review videos. Number two, work odd problems of the type that are giving you trouble in the homework section. Work odds, you'll know the answer, and you got to figure out how to get that answer. What else can you do? You can go to www.afterschoolhelp.com. This goes right along with our textbook. It's free. Some of you have never been there, and yet the help is there. Go to www.afterschoolhelp.com, Algebra 1, find our current chapter, and work on the lessons that are giving you trouble. If you don't do this, nothing's going to change. What I've been noticing through the homework that you've turned in is that many of you are missing some key concepts. Are you watching all my videos? Are you watching them in regular speed? Are you thinking about the answers, or are you just copying down what you're hearing? It's really important. Are you reading each lesson as I assign it before watching the video? These are all key aspects to your understanding. I hope you're involved in doing all of these. Remember, you can email me questions. I'll help you out. Some have done that, and take advantage where you can. All right, let's get on with the review. Okay, so simplify. Assume that all variables in the rata can represent non-negative values. So when you see that, it means you don't need to worry about the absolute value. Some of you are a little bit off on that still. Well, let's go ahead and get going. Now, I've been talking about showing your work because, again, you have to understand where things are coming from. So let's first deal with the numbers here. I'm looking at number 18. First off, I notice the index is a cube root. I mean, you got to notice the index. So I have a cube root, so I now need 3 of any factor to be able to take the cube root. So I'm looking at my numbers. A 9 is a 3 times 3. There's 2 3s, and there's the third. So what's the cube root of 3 times 3 times 3? It's a 3, and I have a 3 out. Now I'm going to start working my variables. Okay, a to the 5th is an a cubed times a squared. Why did I choose that? Because I want to match the index right here. So what's the cube root of a cubed? It's a. I get an a out. Again, notice how I'm crossing things out. Now, also notice, here's 2 a's, and there's a third a. So again, a cubed, what's the cube root of a cubed? I get a second a out, or a times a, or a squared. How about my b's? So actually, now that I think about this, this was on the last video, wasn't it? Oh, well, it should have been 19 through, but that's okay. Let me finish it. B squared, I have 2 of them. Here, I'll use 1. So there's 3, right? And that's a b. And b cubed left. And there's a b. And so I should have written it this way, like that. And so a 3a squared b cubed. All right, let me get to 19. All right, 19. Notice the distributive property, right? We all know the distributive property, a times the quantity b plus c equals ab plus ac. All right, so distributive property. So that's what we're going to do here. We're going to distribute the square root of 35. But you have to pay attention to what's going on this first distribution. Watch. We have a 35 times a 7. On the second distribution, we have a 35 times a 5. And you might say, well, why didn't you multiply those out? Because I need to unmultiply to simplify. And why would I want to waste my time? I want to S-bump, simplify before I multiply. What's 35? 5 times 7. Do you see now how you have the 2 7s? That's a 49. The square root of 49 is a 7. A 7 comes out. That's a 7 times the square root of 5. How about this second one? Well, here again, the 35 is a 5 times 7. On this one, you have a 5 times 5. Square root of that is a 5, and that's your answer. 7 times the square root of 5 plus 5 times the square root of 7. Same thing here on this one, distribute. So again, Be careful how much you do in your head. Some of you can handle it in your head, some of you cannot. So let me I'll complete this part, then I'll do the back distribution. 2 times 5 is a 10. Do you see how I have these two 2's? The square root of 2 times 2 is a 2. I get a 2 out. The square root of a g squared is a g. I get a g out. What's still left in? Square root of 5. And now let's finish the distribution. So I have this negative 3 out front. I'm going to give here, let me do it here. I have this negative 3 out front. Let me erase this. So I have this negative 3 out front, and then inside I have the 10g from the front times the 15 from the back. So again, I'll work the numbers. 10, 2 times 5, 15, 3 times 5. So notice here, I'm going to get a 5 out. All right, so let me come down here and keep track of everything. So 5 times 5, I get a 5 out. So that's a negative 3 times a 5. And that's it. That's the only numbers I can get out. And now that I look, I only have 1g. I can't get any of those out either. And what's left in is the 2 times the 3 and the g. So let's finish it out. 2g times the square root of 5 minus 15 times the square root of 6g. Now look, some of you are showing no work. And I had students ask me, well, what work am I supposed to show? Look at the work. Are you telling me you're doing all this in your head? I don't think so. I don't think so. So again, you need to work it through, and that's the explanation. 21. All right, so when you look at 21, you have to notice the denominator. And remember, we can't have radicals in the denominator. And so remember the phrase, rationalize the denominator. Well, I need to be able to take the square root of the bottom. So I'm going to multiply it by a square root that will allow me to take the square root of the bottom. Well, if I multiply it by the square root of 6 on the bottom, look where that takes me. Square root of 6 times square root of 6 is the square root of 36. Can I take the square root of that? It would be a 6. Okay, so that's what I was after. But remember, whatever you do to the bottom, you got to do the same thing to the top. So the top becomes 5 times the square root of 6. So our final answer, 5 times the square root of 6 over 6. Now, 22. Students keep missing this aspect of a 27. So a 27 is a 3 times 9. And a 9 is a 3 times 3. So I don't need to rationalize this denominator. I don't. I can already simplify the denominator. What's the cube root of 3 times 3 times 3? It is 3. And that's it on this one. Cube root of 3 over 3 is the answer. Now, for the sake where you have a problem where you do need to rationalize with a cube root, let me do another example here. Suppose we had 5 over the cube root of, let's go 20. So notice what I'd have to do. I want to factor this 20 into a 4 times 5. And I want to factor the 4 into a 2 times 2. So when I rationalize my denominator, I know I need 3 of everything. I already have 2 2's, so I need a third 2. I only have 1 5, so I need 2 more 5's. And that's what I would do. Whatever I do to the bottom, do the same thing to the top. Notice as I now rationalize the bottom, 1 2 3 2's, I get a 2 out. 1 2 3 5's, I get a 5 out. My bottom's going to be a 10. My top is 5 times the cube root of 2 times 25 is 50. And notice here, you can always reduce. This 5 and that 5 reduce, and you get the cube root of 50 over 2. All right, rationalizing with cube roots. Let me do 23 here. So that was just bonus for all of you that are watching. All right, number 23. Again, I got to rationalize my denominator, but I want to simplify first. 3 times 9. So here, let me get some space. I'm going to come over here. I got the square root of 7x on the top. What's this? Square root of 9? I already have a 3 out. Hey, what's the square root of x squared? X, I can get an x out. So now the only thing left in is the square root of 3y. Now see how much more simple the rationalizing is? So I have 1, 3, I need a second. I have 1y, I need a second. Whatever I do to the bottom, do the same thing to the top. Now it's top times top. So that's 21y, 21xy, right? And the bottom, I still have my 3, I still have my x. Now when I rationalize square root of 3 times square root of 3, I get an additional 3 out. And y times y, I get a y out. So clean it all up. Numerator, 21xy. Bottom, 3 times 3 is 9, xy. There's your answer. Square root of 21xy over 9xy. And again, some of you say, what work? Yeah, this. There's the work. And how else you getting there? I don't know. Well, I do know. You're getting there off the back of the book, or you're getting there off the internet, and you can't do that. And why can't you do it? One, it's not moral. But second, you're not learning. What's the whole purpose of what you're doing? It's to learn. So you can't short circuit your learning. Okay, division. So now we've got a problem like this. Look, with 24 here, notice all these powers. I got big powers. There's a lot of simplifying that can go on here. So what they want you to do in this one is they want you to put it back together under one radical, because I got some reducing that I can do here. Okay, so let's reduce. The 2 and the 8 leaves a 4 on the bottom. 4 of these on the bottom wipe out 4 of the ones on the top, and there would be, what, 8 on the top. And with the y's, 3 of these on the top wipe out 3 of these on the bottom. So look where I'm at right now. Now I'm going to split it back up. Top, square root of x to the 8th. Bottom, square root of 4y to the 6th. And look at this thing. What is the square root of x to the 8th? It's x to the 4th. Now there's 2 ways to get there. You can either do x to the 8 over the index 2, or you can think of it as x squared times x squared times x squared times x squared, right? Isn't that x to the 8th? What's the square root of x squared? X times x times x times x, x to the 4th. On the bottom, square root of 4 we all know is 2. And again, can you do the square root of y to the 6th? So 6 divided by 2 is 3. It's y cubed. And again, what's the other way of thinking of it? Y squared times y squared times y squared, right? Square root of that is a y, second y, third y, y cubed. All right, x to the 4th over 2y cubed. 25 is an addition problem. Now we got to change our thinking. Now we got to start thinking about similar radicals. So you can only add similar radicals. Now right now, I can add this one and those. 1 of them and 5 of them and 6 of them. Now if that's all I do, I'm not going to complete the problem. What gets students here is you always have to look to simplify radicals. I've got a 24. 4 times 6 is 24. So I can take the square root of 4 and get a 2 out. So this is a negative 2 times the square root of 6. So now look what I've got. 1 of them minus 2 of them is a negative 1 of them. A negative 1 of them and a positive 5 of them is a positive 4 of them. 4 times the square root of 6. 4 times the square root of 6. And again, notice the work there, right? There's work. Next one, simplifying. This is a 2 times 9. Square root of 9 is a 3, so 3 times square root of 2. This is a 3 times 4. Square root of 4 is 2, so this is a, whoops, got my plus sign right from there, plus 2 times the square root of 3. And then I have the square root of 8, 2 times 4. Square root of 4 is 2, so plus 2 times square root of 2. Okay, now I can only add these. 3 of them and 2 of them is 5 of the whats? Of the square root of 2's. And then I still have this, plus 2 times square root of 3, and I can't add those. You can't add a square root of 2 and a square root of 3. They're not like terms. And so that's our final answer. And you can reverse the order. You can have 2 times the square root of 3 plus 5 times the square root of 2. All right, that's 26. 27, more adding, but now we're doing cube roots. So again, I'm looking for cube root of things. 56. 7 times 8 is 56. Most of you should know that the cube root of 8 is 2. So I now get a 2 out in front, right? And so this is a cube root of 7. Okay, that's handy. And you know what? Being there's a lot of 7s, I'm going to look at that 189. I'm going to grab my calculator. I'm going to divide it by 7. I'm just curious. 189 divided by 7. Oh, is a 7 times 27. Okay, so the 27 I know is a 3 times 9, and the 9 is a 3 times 3. And do you see my 3 3's, right? We're doing a cube root. What's the cube root of 3 cubed is a 3, so I get a 3 out. Now notice I still have the negative sign, and what I have left in, the cube root of 7. So now watch. 1 of them plus 2 of them is 3 of them. 3 of them minus 3 of them leaves none of them. And none of them is none. 0. The answer to 27 is 0. And that's why, and that's the work to the problem. All right? Is there work to it? You better believe there's work to it. That's the work to it. Look, if you're just punching this in your calculator, you are misunderstanding all of what's you're supposed to learn with the numbers so you can do it with the variables. Because you're not punching 28 in your calculator, are you? So again, don't short circuit your learning. You got to learn how to do the math. All right, 28. So again, I'm looking to simplify because I'm looking at addition. I know they all got to match. I can only add stuff that matches. 32. 4 times 8 is 32, and 8 is 4 times 2. All right, 4 times 4, I get a 4 out. So this is a 4a times the square root of 2a. Second one, 8, 2 times 4. All right, square root of 4 is 2. There's my plus sign, right? I'm getting a 2 out. And notice the a cubed is an a squared times a. What's the square root of a squared? A. I'm getting an a out. What's left in? Square root of 2a. Last term, 18, 2 times 9. Okay, what's the square root of 9? 3. So I have this negative sign in between, then the 3. A to the 5th is an a to the 4th times a. What's the square root of a to the 4th? It's an a squared. Now again, 4 divided by 2, but if you don't see it, you can think of it as an a squared times an a squared. What's the square root of a squared? A. What's the square root of a squared? A. That's the a squared. All right, what's left in? Square root of 2a. Okay, adding like terms. 4a of them and another 2a of them is a 6a of them. But now I have this issue of when even though the radicals match, look, these radicals match. The problem right now is, can I add a 6a and a negative 3a squared? And the answer is I cannot. They're not like terms. So here's one form of the answer which is acceptable right there. However, if you understand the distributive property, you might also write this as the answer, and they're exactly the same thing, and I'll take it either way. Okay? Either answer. All right, 29, multiplying binomials. So in this one, you can do some stuff in your head, but boy, you got to understand what's going on. I'm going to show it to you and not do it in my head. Square root of 2 times square root of 2, right? What's the square root of 2 times 2 is a 2, so that's that one. Square root of 2 times a negative square root of 3 is negative square root of 6. Nothing you can do with that. Back distribution. Positive square root of 3 times positive square root of 2 is positive square root of 6. No simplifying. But in the back, positive times a negative is a negative, and you get the square root of, here I should be doing this up above. Do it up here. Positive times a negative is a negative, and you get the square root of 3 times 3. And what is the square root of 3 times 3? It's a 3. So here's where we're at. Let's add 2 positives and 3 negatives, leaves you a negative 1. And what do you get when you add these two up? You get 0. The answer to 29 is negative 1. Again, should there be work? Yeah, there's work. That's the work to it. All right, number 30. What the students get confused with, and that's the algebra rules. You can't use an algebra rule on a binomial. You have to multiply it out. So this is 5 times the square root of 2 minus the square root of 3 times 5 times the square root of 2 minus the square root of 3. So again, let me try to do it part by part for you. I'm going to distribute. 5 times 5 in front is 25. And again, to be clear, square root of 2 times square root of 2 is a square root of 4. So I'm going to get a 2 out, correct? Comes out in front, and this first number is a 50. Second distribution. 5 times a negative 1 is a negative 5. And square root of 2 times square root of 3 is square root of 6. There's nothing else you can do with that. That's a 5 times the square root of 6. Distributing the back times the front. Negative 1 times a 5 is a negative 5. Square root of 3 times square root of 2 is square root of 6. We have another negative 5 times the square root of 6. In the last distribution, negative times a negative is a positive, and the square root of 3 times 3 is a 3, so we get positive 3. So on this one, adding up my numbers, there's a 53. Adding up my radicals, a negative 5 of them and another negative 5 of them is a negative 10 of them. 53 minus 10 times the square root of 6. And again, commutative property, you can switch the order, right? You can have negative 10 times the square root of 6 plus 53. Okay, last two. Rationalizing the denominator using conjugates. What is the conjugate? It's a binomial, and it forms a difference of 2 squares. How do you get it? It's easy. Put what you have and change the middle sign. All right, everything else is the same. If the first one had a plus, make the second one have a minus. Second one has a plus, make the second one have a minus. You know, if I do that over here, right, because I'm going to have to rationalize this one, notice I'll do the square root of 3. The first had a plus, so now I put a minus, so now I put a plus, right? And that would be the rationalizing of that one. Okay, whatever you do to the bottom, do the same thing to the top. Now, as I told you, I always do the bottoms first because sometimes the thing reduces before multiplying out the top. So let me do the bottom. Square, or 3 times 3 is a 9. Now let me remind you one more time. The outers plus the inners always add to 0, so I don't need to worry about them. But that's only for a difference of two squares or when you're multiplying by conjugate, so be careful. All right, and then finishing off, a positive times a negative is a negative. I get negative the square root of 2 times 2, which is a negative 2. So my bottom is a 7. Okay, this 7 will not reduce with this 6. So I understand I got to finish this thing out. So what's my bottom? It's a 7. 6 times 3 is 18. 6 times a negative 1 is a negative 6 times the square root of 2. There's your answer. 18 minus 6 times the square root of 2 over 7. Now this bottom one, or the number 32, again, conjugate. So I'm going to do the same thing on the top. Square root of 3 minus 3 times the square root of 2. Again, I'm going to do my bottom first. Square root of 3 times square root of 3 is square root of 9. Square root of 9 is 3. Again, the outers, let me show it. The outers plus the inners always equals 0 for a difference two squares or conjugates, so I don't need to do them. But always keep it in mind, because when it's not, you have to do it. All right, anyhow. The backs, negative 3 times positive 3 is a negative 9, and then square root of 2 times square root of 2. So square root of 2 is 2, so I get a 2 out. So I get 3 minus 18. 3 minus 18 is a negative 15. Now watch. What I have here is, this is the same as 3 times a negative 5. And you see how these 3's divide out? See, I want to do that now. It saves me all this simplifying. Now this last one, I still have a couple things to deal with yet, so let me go ahead and show you the multiplication top. Square root of 3 times square root of 3 is 3. Square root of 3 times a negative 3 times square root of 2 is a negative 9. Oops, I'm sorry, a negative 3 times the square root of 6. That's my top over a negative 5. Let me clean that up. So this is a negative 3 times the square root of 6. Now, the last thing is, I can't leave a negative in the bottom. So technically, I'm going to multiply top and bottom by negative 1. So let me show it to you over here. I want to show you this. I need to do the top by negative 1. I need to do the bottom by negative 1. I had that negative 5 on the bottom. I had that 3 minus 3 times the square root of 6 on the top. So by doing this, that makes that a plus. Follow? Here, that makes this a negative and makes that a plus. Final answer, negative 3 plus 3 times the square root of 6 over positive 5, because we don't leave negatives in the denominator. Radicals. They're important in your education, in going further in your math. Simplifying starts it all, and then there's a lot of other aspects. So notice I've broken this chapter up into 2 parts, because this first part is the foundational aspects of radicals. You have to know how to simplify them. You have to know how to multiply them. You have to know how to add, subtract, and divide them. This is the beginning aspects of radicals. I hope you'll understand. Hope this review was a help to you. I have a further chapter review of the first half of the chapter. You should have watched that already as well. I hope you're getting ready for the quiz coming and your test. Again, email me if you have any questions. Hope this is a help. All right, have a great day.